Hi class, this is Russ. I thought I would go over the solutions to the first quiz. I believe a number of you had some questions and issues with it. So let me go over some of the solutions. All right, so the first quiz question was the length of time that it takes students to complete their statistics exam is what type of data? Well, since students can complete the exam at any time after the start of the quiz and before the end of the quiz, and there are an infinite number of time values between start and end, this would be an example of continuous data. A survey was conducted to determine the preferred news source for homeowners in Illinois, television, internet, or newspaper. 10,000 households were divided by income level, and households from each income level were randomly selected to participate in the survey. The sampling technique used. Okay, so we had a sample of 10,000 households, and the household sample was divided by income level. The fact that uh, the sample was divided means that it was essentially stratified. So stratified the different strata. So this sampling technique is a stratification sampling. One question was, so we are given weekly salaries of 10 medical assistants, and we want to know the mean salary of the RNs. So based on this data. So probably best to use Excel here. So enter the data, 805, 747, 546, 450, 1109, 975, 809, 767, 450, 690. All right, so we want the mean of these. So in Excel, that's just mean, right? Or average. You can take average. And the cell range is A1 to A10 for this worksheet. So it's 734.80 cents, $734.80. So you could go with choice A for this one. The next question was right here. What is the median? So you can use the Excel median function. So again, select the input range for median. And so that's 757. So choice A for that. Next question. Standard deviation of those salaries. Okay, so you can use this Excel standard deviation. And that's $213.20. So choice C there. Okay, so I believe most of you had difficulty with this particular question. All right, so you have 7 customers in our clothing store and are observed to determine if they will make a purchase. The owner estimates what? 75% chance of a customer making a purchase. Random variable X represents the number of customers making a purchase. What is the probability of that exactly 4 customers will make a purchase? Okay, so this is an example of the binomial probability distribution problem. And so the way you access that solution is here. Go into your module, module 1, review of basic statistics. Go into the review topics link, click on the basic review topics link, and you'll get a PowerPoint slide called here G310 Model 1 Lecture. All right, so let's see, do I have it opened up? I don't think so. Okay, so open this up. All right, so I'll save it. Okay. I don't know why it takes so long. Okay. And I believe if you scroll down to slide number 40 in this PowerPoint presentation, you'll see a very similarly worked example. Okay, an example of a binomial probability distribution. So just to review, a binomial probability distribution results from a procedure that meets the following requirements. So the procedure has a fixed number of trials. So in this particular case, the number of trials would be the total number of customers entering the store, which was 7. The trials are independent. That's the case here. Each trial must have all outcomes classified into 2 categories, success and failure. So in this case, in this particular problem, the success would be um, a customer making a purchase. A failure would be a customer not making a purchase. The probability of a success remains the same in all trials. So the store manager estimated that there was a 75% chance that a customer will make a purchase. So for each customer, there's a 75% chance that that customer will buy something. So so the probability of success remains the same for all trials. Okay. Uh, so in this particular problem, n is 7, x is 4, p is 0.75, q is the probability of failure. That is the probability that a customer will not buy something. So q is 0.25. And P of X denotes the probability of getting exactly X successes among N trials. So in this case, we want P of 4. All right, so this is the formula we use to solve this. P of X equals N. Okay, so let me explain in my whiteboard how this works. So in my whiteboard, the binomial probability formula is written as P of X equals to N factorial divided by N minus X factorial times X factorial times P to the X Q to the N minus X. So for this problem, N is 7, X is 4, P is 0.75, and Q is 0.25. Okay, so let's calculate the coefficient. So the coefficient would be 7 factorial divided by what? 7 minus 4 factorial times 4 factorial. So that's equal to 7 times 6 times 5 times 4 times 3 times 2 divided by 3 times 2 times 4 times 3 times 2. So we get a lot of cancellations, right? 3 and 2 is 6. That cancels. 4 cancels. These 3 and 2. This 3 and this 2 will cancel. All right. So that's just equal to 35. All right. So the probability of 4, you would write, is equal to 35 times 0.75 to the 4th power times 0.25 to the 3rd power. Okay, so I'll use my calculator for this. So I have 35 times 0.75 to the 4th power times 0.25 to the 3rd power. And so that's a 17.3% chance that 4 customers will make a purchase. I believe the next question was a probability of 5. So just rework the same problem, replacing 4 with 5, and you'll get a different answer. Okay. All right. So what's the next question? Let's see what that is. Pull up my Word document. So actually, that should be need to find P of 4. Okay. Okay. So we want to find the mean, variance, and standard deviation for this particular problem, for this particular binomial distribution. All right. So if we go back to the PowerPoint slides, we're given the formulas for mean, variance, and standard deviation of a probability of a binomial distribution. Okay, and that would be on slide 49. So the mean is just the number of experiments, 7 in this case, times the probability of success. So all we do is mean is equal to 7 by 0.75. Okay, and so that's 5.25. The variance is just the mean times the probability of failure. So that would be times what, 0.25. So that's 1.3125. And then the standard deviation is just the square root of the variance. So that would equal to the um, square root function, wherever that is. Oh, here it is. Okay, so we go second square root 1.3125. Okay, and so that would be 1.1456. All right, so those are the statistics for the binomial distribution for this particular problem. Okay, what next? So the next question was, okay, the length of time it takes students to complete the entrance exam for a university is normally distributed with a population mean of 120 minutes and a standard deviation of 30 minutes. Okay, what is the probability that one randomly selected student will take longer than 165 minutes? Okay, so what we need to do here is calculate the standardized score, the z-score, and then find the area to the right of the z-score, right? So in this particular case, the z-score would be what? 165 minus 120, right? Because x is 165, mu is 120, divided by standard deviation, which is 30. Okay, so the z-score is 1.5. Right, so now we go into our table. Okay, so z-table. So 1.5 is 0.668. So that's the area to the left. So that's what we want, right? What is it? Let me see. Review the question. Will take longer than 165 minutes. Okay, yeah. So that is in fact the the area to the right of 165 would be 0.9332, and so the this is the okay. So check that. So 0.668 is actually the area to the right. So XL is I'm sorry. This z-score, this table is giving us the area to the right of 1.5. So what we really want is, let me think here. Yeah, that's right. That's correct. We want 0.66, yeah, 6.7%. And the 0.9332 is the area to the left of the z-score. So we want not the area to the left, but the area to the right. So to do this in Excel, we would do a norm dist, oops, equals norm, if I can type, norm.dist. X is what, 165. The mean is 120. Standard deviation is 30, and we want cumulative. All right, so that is, okay, so that's the area to the left. And so what we want then basically is the area to the right. So that would be area under the curve is 1 minus this. And so that's a little bit off, isn't it? Did I not enter the numbers properly? Oh, I have 164. I need to make that 165. Sorry about that. Okay, so there's the 0.668 that we seek. So that's the answer, 6.7% chance that the student will take longer than 165 minutes to complete the exam. All right, so one thing to note about this question is that this question deals with the population. And so we use sigma. We do not modify sigma in the computation of the standard score since we're dealing with the population. I believe in one of the questions, the next question, yeah, in the next question is actually a trick question. So they're dealing with a sample of the population. So in the next question, same parameters, right? Mean 120, standard deviation 30 minutes. but we want the probability that the average of 25 randomly selected students will take between 115 and 125 minutes. So now we're dealing with a sample, a sample of 25 students. So when you deal with a sample, you make one assumption. First of all, since the population is normally distributed, the mean of the normally distributed population will be the same. Check that. The mean of the sample from a normally distributed population will be the same as the mean of the population. However, the standard deviation will not be the same. The standard deviation of the sample will be the population standard deviation right here, divided by the square root of the sample size. So in this case, the standard deviation of the sample will be 6. Okay, 30 divided by 6. And now we can use our norm dist with the modified standard deviation. Okay, so we want the area between two standard scores, right? The area between 125 and 115, with the mean being 120 and the sample mean being 120 and the sample standard deviation being 6, and we want it to be cumulative. So we wire this into Excel. Okay, so this would equal to norm dist 125, 120, 61 minus norm dist 125, check that 115, 126, and 1. All right, and so, what happened? Oh, I have them. What is that? Another typo, right? Let me try it again. Sorry, typing too fast here. So equals norm dist 125, 126, 1 minus norm dot dist 115, 126, 1. Hopefully I'll get, 59. So there's a 59.5% chance. So you'll select choice A for this question. Okay, so go over these solutions. If you have any questions about the methods I used, or if you need to see more examples, let me know and I can arrange for a video walkthrough with you on these. So let me know what other issues and concerns you have about this particular quiz. And so I guess this will conclude this particular solution. All right, more later. Okay, have a great day.